Okay, today we're going to be discussing the remainder and factor theorems, and these are our content standards in the mathematical practice we'll use in our assignment today. Previously, you've used the distributive property and factoring to simplify algebraic expressions, and today we're going to evaluate functions by using synthetic substitution, and then we'll determine whether a binomial is a factor of a polynomial by using synthetic substitution. Our new vocabulary today is synthetic substitution and depressed polynomial. Synthetic division can be used to find the value of a function. So let's consider this polynomial, negative 3x squared plus 5x plus 4. And we're going to divide the polynomial by x minus 3. So this is one method. We use the long division. And then we've also learned about synthetic division. Now let's look at the remainder of negative 8 and compare it to f of 3. So if we go in and we substitute 3 in for our function, we're going to get that it equals whatever our remainder is. Isn't that something? So notice the value of f of 3 is the same as the remainder when the polynomial is divided by x minus 3. This illustrates the remainder theorem. And here's our key concept on the remainder theorem. Applying the remainder theorem using synthetic division to evaluate a function is called synthetic substitution. It is a convenient way to find the value of a function, especially when the degree of the polynomial is greater than 2. So let's look at synthetic substitution. We're given a polynomial here and we're asked to find f of 6. So method 1, it says by the remainder theorem, f of 6 should be the remainder when you divide this polynomial by x minus 6. So we're going to do synthetic division, of course. So this is x minus 6, so a positive 6 goes in our box. Bring our 2 down, multiply, multiply, multiply. Now let's see what we get with our constant, our remainder. 2, 4, 5, 3. Notice we had to put a placeholder in because we go from 4 to 2. So in the place of the third, x to the third, we had to put a 0 as a placeholder. So the remainder is 2,453. Thus, by using synthetic substitution, f of 6 is equal to 2,453. So let's use direct substitution where we're going to replace x in this polynomial with 6. So here we've put a 6 in place of x everywhere. And sure enough, we get 2,453 by using direct substitution. Okay, let's give you a moment and a chance to check your own progress. So pause the video, work this problem, then come back and check your answer. Did you get 34? Very good. I did a quick direct substitution and I got 34 for that one. Excellent job. Now, synthetic substitution can be used in situations in which direct substitution would involve cumbersome calculations, such as when we're working these real-world examples. So I'm going to give you a moment to read. So pause the video for a moment and read through the problem. So we're trying to find out how many U.S. college students will study abroad in 2011. So how long is it between 1993 and 2011? It's 18 years. So you need to know that. We've got to know that difference before we can get started. We write our coefficients down with each of our terms, and we get 451.76. So in 2011, there will be about 451,760 U.S. college students studying abroad. Okay, notice they tell us that it's the number of students in thousands, so that's why we get rid of the decimal point and multiply. Okay, give you a moment to check your progress. You may need to go back and look at the previous example, but then work the problem, come back and check your answer. Did you get B, 638,680? If you didn't get this, you might check to make sure that since there is no constant, you put a 0 in as a placeholder. So if you didn't get this answer, try that and work it again and see if you get that. And how many years is it between 1999 and 2013? Well, that's 14 years, so make sure you got a 14 in your little box. Alrighty. Now we're going to look at factors of polynomials. So we're given a synthetic division, and it shows that the quotient of, okay, sorry about that, the quotient of 2x cubed minus 3x squared minus 17x plus 30, and x plus 3, we're told it's 2x squared minus 9x plus 10. We learned how to do this when we studied synthetic division. And remember this, we depress the polynomial. We go down 1 to get that answer. So since the remainder is 0, f of negative 3 is equal to 0. That means that x plus 3 is a factor. Whenever we get a remainder of 0, we know that whatever we put here is a factor of this original polynomial. So x plus 3 is a factor of this polynomial. That illustrates the factor theorem, and that is a special case of the remainder theorem. So this describes our factor theorem. The binomial x minus r is the factor of a polynomial if and only if you've got a remainder of 0. So now let's use the factor theorem. We are to determine whether x minus 3 is a factor of this polynomial, then find the remaining factors. Okay, so if it's a factor of 3 if a 0 is related polynomial function. Use the factor theorem in synthetic division. Okay, so this is a minus 3, so we put a positive 3 in the box. We have a 1, a 4, negative 15, and negative 18. They are in descending order. We're not missing any variables. And we've got a constant. We're not missing that either. Bring your first term down. 3 times 1 is 3. 3 times 7 is 21. 3 times 6 is 18. We have no remainder. So we know that x minus 3 is indeed a factor of this polynomial. Once we get the depressed polynomial, the answer that's left, we can check to see if that can be factored, and this one can. X plus 6, x plus 1. So the factors of this 4-term polynomial are these 3 factors. You can enter in that polynomial and look at the graph to see that it's crossing the x's in the right place. All right, so time for you to check your progress. Pause the video for a moment, work this, and come back and check your answer. Well, yes, and x plus 5, x plus 1, x plus 2 is also a factor. So all the factors of this would be x plus 2, x plus 5, x plus 1. Very good. You're ready to begin working the exercises. Good job, folks.